Now, when we come to the polar coordinate system, I'm just going to introduce you to a very simple, basic graphs that we can make. Well, here's our polar system. And we're going to look at simple graphs. The simplest graph to do is r equals 2. That means all the points whose radius is 2. That will be a circle here. R equals 2. If you want, I'll do some of the other colors. Suppose I want R equals 3.5. Well, 1, 2, 3.5. So this would be R equals 3.5. So a graph R equals a number is just a circle with the center at the origin at that particular radius. So R equals A is a circle with radius A. Okay, that's pretty easy. Graphing circles on a polar coordinate system is very easy compared to graphing a circle on a rectangular system. On a rectangular system, you have x squared plus y squared equals r squared. And so you have a whole lot more involved in trying to calculate the x and y coordinates for a circle. But in a polar one, it's just radius equals the radius, the number. Now, let's take a look at lines on the polar coordinate system. Here, we define a line not by its slope, but by its angle measure. So if I say theta equals pi over 4, that means this line right here. This is theta equals pi over 4. It goes through the unit circle here at pi over 4. And that's a line. Let's draw a line like this. This might be theta equals negative pi over 12. So negative pi over 12 here, and so that's the line. So again, drawing lines in a polar coordinate system is a lot easier of an equation to write than when we write lines in a rectangular coordinate system. We use y equals mx plus b, or we use ax plus by equals c, or some other more complicated formulas. So in some sense, certain things are much easier to graph on a polar coordinate system using the polar references than graphing on a rectangular system. I want to conclude this section by how do we find the distance between 2 points.